Alrighty, those of you that were with me this morning know that I made so many mistakes. We didn't even get to today's lesson. So we're going to go on and take a look at section 10.4, part 1. Okay. So let me get myself organized here a little bit better. And what I want to do right now is I want to switch from this screen to a graphing screen, and hopefully that's working, which it is. What we're going to be doing today is graphing quadratic or second degree equations. And the graphs of these things are not straight lines. Let's start off with just graphing the simple equation y equals x squared. All right. And I'm going to pick values. What I tend to do when I'm graphing something that I don't know anything about and I'm just starting from scratch, I tend to start graphing from -3 to +3 in terms of my x values. So let's go through and let's complete this table. If x is -3, then y equals -3, but it's -3 the quantity squared. So we in fact get a +9. So we don't get -9 because we're taking -3 times itself. Okay. If x is -2, y equals -2 the quantity squared is 4. If x is -1, y equals -1 the quantity squared, which is 1. 0 the quantity squared is 0. 1 the quantity squared is 1. 2 the quantity squared is 4. And 3 the quantity squared is 9. Notice on our table, we've got some identical values. When x is -3 and x is +3, we get the same y value. When x is -2 and x is +2, we get the same y value. And when x is -1 and x is +1, we get the same y value. Sorry about that. Okay, now, what does our graph look like? Well, let's see here. -3, 9. -3, 9 is right there. -2, 4, right there. -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. Can you see that that is definitely not a linear equation? All right, let's see if I can draw this thing. Well, close. Okay. That is called a parabola. Okay. There are several characteristics about a parabola. One of those is that it has what is called an axis of symmetry. If you notice, for this particular problem, if we emphasize the y-axis here, that this graph is symmetric about the y-axis. This distance is the same as that distance. This distance is the same as that. Again, corresponding to our matching y values in the table. Okay. So every parabola has an axis of symmetry about which the parabola is symmetric. In other words, if we graphed one half of it, we could just reflect across and graph the other half of it. Okay. Now, some other characteristics of a parabola. A parabola either opens upward, like this one did, or it opens downward. We'll look at that some more in a bit. And a parabola has a vertex. A vertex, if it opens up, it's the low point. If it opens down, it's the high point. Right here, this has a vertex at 0, 0, at the origin. Okay? So this 0, 0 is the vertex of the parabola. That's going to be very important when we start graphing on Webassign, and we'll get there shortly. All right, now what I want to do is I want to erase this and this. In fact, let's just erase all of this, but let's keep that original graph there, okay? And let's go back here. Here, okay, and we had the following information. We had, was it what? -3, 9, -2, 4, -1, 1, 0 there, there, and there. Okay, let's see if I can draw this again without all that extra mess. Hey, did even better. Okay, now, what I want to look at is the graph of y equals 2x squared. So I want to put a coefficient in front of that x squared that's bigger than 1. And let's see what that's going to do in terms of our graph. I'm still going to use the same x values or input values that I did before. But now we're going to take 2 times x squared. Notice that the x squared, the -3 squared, order of operations, we would do that first. So we square it and then multiply it by 2. So this becomes 18. Well, so how does this compare to that? It's the same thing times 2. So this is going to be 8, 2, 0, 2, 8, and 18. Do you see how I did that? 2x squared is just x squared doubled. Let's do that in a different color. Let's make that graph red. Well, -3, 18 is up off the graph. So I'm not going to graph these two numbers. But -2, 8, that's right here. -1, 2 is right there. 0, 0, 1, 2, and 2, 8. So my graph looks like that. Can you see that by in comparison to y equals x squared, y equals 2x squared is opening, it's not, it's climbing steeper faster, okay? Does that make sense? All right, now what I want to do is, let's take a look at y equals, let's do that. Let's go back to black there. Y equals 1/2 x squared. And let's make that table. Okay, let's see. If x is -3, we'd have y equals 1/2 times -3 squared, which is 1/2 times 9, which is 9/2, or 4.5. Okay? If x is -2, y equals 1/2 times -2 squared, which is 1/2 times 4, which is 2. Oh, again, do you see what's happening? Now, order of operations, we're taking x and squaring it. So we're going to get the 9, 4, 1, 0, 1, 4, 9. But then we're cutting it in half. So this is half of that. This is half of that. This would be 1/2, 0, 1/2, 2, and 4.5. Because these y values are half of those y values. Just like these y values were twice that. So now instead of doubling it, we're cutting it in half. Let's graph this in green. Okay. So -3, 4.5, -2, 2, 1/2, 0, 0, a half, 2, 4.5. I don't know if you can tell very well, but this is opening wider. It's climbing not as steep. So the black graph was y equals x squared, okay? The red graph, 2x squared, was climbing steeper. The green graph, 1/2 x squared, was climbing not quite as steep, okay? I want to put one more graph on this. So let's see here. Let's go back to black there. And let's look at y equals negative x squared. -3, -2, -1, 0, 1, 2, 3. Now, order of operations, y equals negative times -3 squared. What do you do first? You square, you do the exponent first. So this is going to be 9 with a negative sign in front of it. This is going to be 4 with a negative sign, with a negative sign, with a negative sign, with a negative sign. Well, -0 is the same thing as 0, but I'm going to square it just like the beginning one, but then make it negative. So now all my y values are the opposite of what they were for x squared. So y equals negative x squared. What does that look like? Well, let's see here. -3, -9. -2, -4, -1, -1, 0, 0, 1, -1, 2, -4, 3, negative. Oh, we get a parabola that opens downward. Okay, let's generalize on what we've looked at. If we have an equation in the form of y equals ax squared, if a is greater than 0, the parabola opens up. If a is less than 0, the parabola opens down. Okay? And compared to y equals 1x squared, if a is bigger than 1, it tends to move like this. If a is between 0 and 1, it tends to widen. And if a is negative, it's going to open downward. All right. Now, from there, I want to go to a new page and put on a new graph. And let's see, blank. All right, let's go back to y equals x squared, okay? -3, -2, -1, 0, 1, 2, and 3. And this is 9, 4, 1, 0, 1, 4, and 9. In the graph, 3, let's see, 2, 4, here, 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 here. Okay, let's graph this thing. Now, what if I had y equals x squared plus 2? So I've got a whole separate term plus 2 outside there. Okay. -3, -2, 1, 2, 3. So following order of operations, y equals -3, the quantity squared, plus 2, which is 9 plus 2, which is 11. Y equals -2, the quantity squared, plus 2, which is 4 plus 2, which is 6. Well, how do these values compare to those values? Isn't this just this plus 2? Y squared, y equals x squared, and then y equals x squared plus 2. So 1 plus 2 is 3, 0 plus 2 is 2, 1 plus 2 is 3, 4 plus 2 is 6, and 9 plus 2 is 11. What does that do to our graph? Let's draw that in red. Okay, -3 is at 11, -2 is at 6, -1 is at 3, 0 is at 2, and then 3, and then 6, and then 11. Now, it's kind of hard to visualize this, especially with my sad-looking drawings, but the shape of the red graph is the exact same shape as the black graph. It's just that the red graph has been shifted upwards by 2 units. Okay? Let's take a look at another example. And let's see here. Let's make the graph of y equals x squared minus 3. Well, how does this graph compare to that graph? Here we have x squared, but then minus 3. So if we take these y values and subtract 3, 9 minus 3 is 6, 4 minus 3 is 1, 1 minus 3 is -2, 0 minus 3 is -3, 1 minus 3 is -2, 4 minus 3 is 1, 9 minus 3 is 6. What do those look like? Well, let's graph those in green. -3, 6, -2, 1, -1, -2, 0, -3, 1, 2, 2, 1, and 3, 6. The shape of the green graph is the shape of the black graph is the shape of the red graph. But now, instead of it going up 2 units like the red one did, it went down 3 units. Okay, so let's generalize on that idea. If we have something of the form y equals ax squared plus k, if k is positive, it's going to shift the graph upwards k units. If k is negative, it's going to shift the graph downward k units. So if I have the graph of y equals x squared, then y equals x squared plus 5 would be the same graph moved up 5 units. Y equals x squared minus 10 would be the same graph shifted down 10 units. Let's go back to the previous page. Did you notice that all of these graphs that I made, they were all in this form, and they all had the vertex at the origin? A graph in this form, y equals ax squared, has the vertex at the origin. Well, here, this one has the graph at the origin, right? The first one. This one has the graph where it's moved up 2 units. It's at 0, 2. This one, the green one, has the graph at 0, -3. So this constant out here, by shifting the graph up or down, shifts the vertex up or down. Okay, now why is that so important? Because ultimately here, when we start graphing, we're going to identify the vertex and go from there. Okay, all right. If I had an audience, I'd say, are there any questions? But oh well. Now, let's go to a new page and look at a new idea. Okay. There's a 5 and a 10. Okay. Again, I'm going to start with y equals x squared. So -3, -2, -1, 0, 1, 2, and 3. This was 9, 4, 1, 0, 1, 4, 9. And let's see, 1, 1, 2, 4, 3, 9. And over here. Okay. All right. So there is y equals x squared. Now we're going to go inside. So instead of having x squared plus 2, we've got x plus 2, the quantity squared. So I'm changing what's inside being squared. Okay? Let's see what that does. All right, so order of operations. When x is -3, we'd get y equals -3 plus 2, the quantity squared, which is -1, the quantity squared, which is that right? -3 plus 2, -1. Yeah, that's 1. Okay. That just seems weird, but all right, if x is -2, y equals -2 plus 2 squared, which is 0 squared, which is 0. If x is -1, y equals -1 plus 2 squared, which is 1 squared, which is 1. The reason I hesitated is I'm having a Monday and I thought, oh, did I mess up again? But I think we're safe. Y equals 0 plus 2 squared is 2 squared is 4. Y equals 1 plus 2 squared is 3 squared is 9. Y equals 2 plus 2 squared, which is 4 squared, which is 16. And y equals 3 plus 2 squared, 5 squared, 25. Okay. Now, I'm going to erase all my calculations there because I might need that room. Let's see. -3, 1. -2, 0. -1, 1. 0, 4. 1, 9. 216, 325. Those aren't, I'm not going to be able to graph those. You know what? Let's go the other direction. Just let's go -4 and -5. Just see what happens. In other words, go like up above here in the table. -4. Y equals -4 plus 2 squared, which is -2 squared, which is 4. So -4 is at 4. And then -5. Y equals -5 plus 2 squared, -3 squared, 9. -5, 9. Oh, what does that graph look like? Well, it's the same shape as y equals x squared, except it's moved which way? It's moved to the left 2 units. By adding 2 inside, it moved to the left, so it moved to a -2 direction. Why is that? Well, consider it this way, okay? Here we're starting out with x and we're squaring it. Here we're starting out with x plus 2, so we're already 2 ahead. So if our x values are 2 less than they are over here, I get the same resulting y value. So that means everything, the black graph shifted to the left 2 units and resulted in the same y values. Okay? That's a little harder to swallow, I know. Now let's do this. And let's go back here and let's take a look at y equals x minus 3 squared. So what do you think that's going to look like? If the plus 2 moved it 2 units to the left, what would the minus 3 do? It would move it 3 units to the right. So I can take this point and go over 3, and this point and go over 3, and this point and go over 3, and this point and go over 3. And let's see here, over 3, and I get this graph. Okay, so if I've got a equation in the form of y equals, let's see here, x minus h squared, it's going to move h units. So like here, minus 3h is 3, so it's going to move 3 units to the right. Here, plus 2 would be minus -2. It's going to move 2 units to the left. That's going to be a little hard to swallow, but you'll get used to it. All right, so here's what we've got with this whole mess. We're going to kind of summarize here what's going on. Actually, it's kind of nice that I screwed up this morning, because now I can take all the time I need, make this 3-hour-long video, and you'll all just love it. Maybe not, maybe not. All right. Y equals a times the quantity x minus h squared plus k. All right. K moves it up or down. H moves it side to side. A changes its shape, whether it opens narrow or wide or flips over. All right. What we're most concerned about is the vertex, the lowest point if the graph opens upward, the highest point if the graph opens downward. Because when we go to graph in Webassign, we're going to find the vertex and then just one other point. We don't have to find a whole bunch of table points in Webassign, but outside of Webassign you would. So that's why I went through all this rigmarole to start with. Let's say we've got y equals 2 times x minus 3 squared plus 5. All right. Where's the vertex? The vertex is at hk, which is 3, 5. So 1, 2, 3, 5. So there's the vertex on the graph. Okay. That's all I'm going to do with this problem right now. I'm going to go on to another one. Come on. Move that thing out of the way so I can add a page. Okay. Ooh, those lines didn't get very straight. Let's try that again. Sorry about that. Here I am trying to hurry again. Got me in trouble before. All right, let's say y equals -3 times x plus 2 squared minus 5. The vertex is at hk. So that would be -2, -5. And you're going, where did I get the negative? Well, this would be like x minus -2. So h would be -2. All right. And then that's your y value. So -2, -5 is down there. I also know this thing's going to open downward, don't I? But again, find the vertex. We can go from there. Now, what I want to do is I'm going to go to Webassign. So let me open that up. Let's see. Hang on here a minute. I got to go back up here to there and close that up. Hang on. Did this thing finish? Yes, it did. Good. So we're going to find it here. Webassign. to open student view. I don't want that. .4 part 1. Come on. Okay. All this just to get a picture. Okay. So now let's take a look at Webassign. So here it says, make a table of values for each function and graph them on the same coordinate system. Okay. And just a second here. So I've got f of x equals x squared, and then g of x equals 6x squared, and finally, let's see, s of x equals 1/6 x squared. Okay. What I'm going to do now that I've got this graph formed is or this grid ready, I'm going to go back to my board and do some calculations. Okay. And let's take a look at f of x equals x squared. Oh, we're using function notation. Well, yeah, a parabola is a function. For each x, there's exactly one y. And you're going, wait a minute, we had a bunch of y values that were the same. Yeah, different x's can go to the same y. Two people can have the same birthday, but you can't have one x going to two different y's. So it is a function, all right? Now, so f of x equals x squared, that's basically just like y equals x squared, okay? Do you remember where the vertex is on that thing? The vertex would be at 0, 0. In fact, on all of these graphs that we're going to do, the vertex is 0, 0. But let's find another point. What if x is 1? What would y be? F of 1 equals 1 squared. Y is also 1, right? Okay, so here's the vertex. And then here's another point. All right, now I'm going to go back to Webassign. Over here on the left, I'm going to click on the parabola-shaped button until it turns blue. Now, this is critical. We're going to plot 2 points. The first point has to be the vertex, or your graph's going to be wrong. So I'm going to come over here. The vertex was at 0, 0, and then the other point we had was at 1, 1. And there you go. There is the graph of f of x equals x squared, or y equals x squared. Let me show you what happens if I do it incorrectly. Okay. Now, I know it contains the point 0, 0, and 1, 1. Let's go and let's plot the 1, 1 first, and then the 0, 0. See what it did? It opened the wrong direction because it only understands that the first point is the vertex, and then the second point helps it get the rest of the graph. So you've got to plot the vertex first. And you're thinking, why am I going on and on about this? Because last quarter students, especially ones that never came and watched the videos, got completely lost with it. Okay, so going back here, let's see here. I've got 0, 0, and 1, 1, and there's my graph. Okay, now let's go back to this screen. And red, let's see here. This is like y equals 6x squared. Well, the vertex is still at 0, 0. What about when x is 1? What's g of 1? That would be 6 times 1 squared, 6 times 1, or 6. So that's at 1, 6. Okay? So again, I've got the vertex here. Vertex, and then other point, or another point, another point. So back over here to Webassign and make it blue, 0, 0, and 1, 6. And there's g of x equals 6x squared. All right. And let's go back here and take a look at the green graph. Okay, so y equals 1/6 x squared. I guess that's a different shade of green than I had before. Again, I know that 0, 0 is the vertex. When x is, tell you what, let's make it, yeah, let's make it 1. If x is 1, s of 1 is 1/6 times 1 squared, which is 1/6 times 1, which is 1/6. So now my graph is at 0, 0, 1, 1/6. Now things are going to get a little trickier, but we can deal with this. So I've got 0, 0, and then 1, 1/6. Well, I have no idea where that is, and I'm just going to plot it right there. Okay. Now I plotted a straight line, but what I can do, I can go over here. This is parabola number 3. My ordered pairs. The first point, which was the vertex, was 0, 0. The second point was 1, 1/6. And there you go. So you don't have to get it perfect on the graph the first time. You can go over and adjust it, but you've got to graph the vertex first. Okay. Let's see here. I want to do this one. Okay. Here we're supposed to graph f of x equals 2x squared. And then g of x equals 2 times the quantity x plus 7 squared. And then, let's see here, s of x equals 2 times the quantity x minus 2 squared. Okay. So f of x equals 2x squared. Again, that's like y equals 2x squared. Okay. That's of that form, y equals ax squared. So where's the vertex? It's at 0, 0. Okay. And then when x is 1, f of 1 would be 2 times 1 squared, 2 times 1, or 2. So f of x equals 2x squared is at 0, 0, and 1, 2. I know this is taking a long time, but it's going to come in useful. Trust me. So 0, 0, and then 1, 2. So there's my first graph. Okay. Let's take a look at the red function, which is like y equals 2 times x plus 7 squared. Well, where's the vertex? It didn't go up or down, but it moved on the inside. The x value moved. So my x value is going to be -7. And my y value is going to be 0. Because if I take this and I think of it as y equals a times x minus h squared plus k, k is 0, h is -7, because x minus -7, okay? So my vertex is at -7, 0. And what if x is 1? Then I get, let's see, g of 1 would be 2 times 1 plus 7 squared, 2 times 8 squared, 2 times 64. Wow, is that 128? Is that right? Oh, that's kind of ridiculous, isn't it? So here's a way we can get a nicer number. Consider this, okay? If the vertex is all the way over here at -7, 0, wouldn't it be better to pick values close to the vertex rather than just going back to 1? Before, when the vertex was at 0, 0 and I picked 1, it was close to the vertex. But what I'm getting at is, instead of choosing 1, let's pick something really close to the vertex. How about -6? So like just 1 to the right. Now let's see what happens. G of -6, 2 times -6 plus 7 squared, 2 times 1 squared, 2 times 1, 2. So -6, 2. So here again, this is the vertex, and this is our, so vertex and then our other point. Okay, so we're going to go back here and turn that blue, -7, 0, and -6, 2. Look at the picture. Isn't this graph over here the same shape as the first one, but it's moved 7 to the left? So what do you think this other one here is going to be? It's going to be 2 to the right, isn't it? So we don't even need to go back and look at the other screen. Let's just go 2 to the right. So there, and then what? Up 1 and over 2, just like this is up 1 and over 2. There you go. The graphs are all the same shape. The first one is the one in the middle. The 2 times x plus 7 moves 7 to the left. The 2 times x minus 2 moves 2 to the right. So it's kind of like inside inverse. Okay. Now, let's see here. Let's take a look at this one. By now, you're probably falling asleep. But we've got f of x equals 1/4 x squared, which is y equals 1/4 x squared. Okay. Now, the vertex is still at 0, 0, right? Because it's in the form y equals ax squared. Okay. Let's see. So let's pick a nice number. How about if we pick 4? Let's see what's going to happen, because f of 4 would be 1/4 times 4 squared, which is 1/4 times 16, which is 4. Okay, so 0, 0, 4, 4. Zero, 0, 4, 4. All right, now, so there is f of x equals 1/4 x squared. G of x equals 1/4 x squared plus 2. That plus 2 that's outside of the square, that's a constant term, that's k. Plus 2 is going to move it up. So it's going to move up 2 units. This number goes up 2, and this number goes up 2. And there we have it. How about this one? 1/4 x squared minus 4. Go back to my original, which was here. This one goes down 4, and this one goes down 4. And there you go. Let's see if they're right. There you go. Okay. So where are we at? Let's do one more that has both of them. Let's take a look at this problem right here, number 14. And there's one more piece of information I need to talk about. So in fact, let's go back to our y equals screen, or to our white screen. Okay. So I've got this y equals a times x minus h squared plus k. And we said that the vertex is at hk. The axis, can't spell, axis of symmetry, that's a dotted line. That's a lousy drawing. Here I go trying to hurry again. Slow down. Let's see, I've got this graph and it looks like this. Okay. The axis of symmetry is a dotted line that goes right through the vertex. And it is, the equation of that would be x equals h. So it goes right through the x value of the vertex. Okay. So how does that work for this problem we're going to do here? And then I'm going to let you go. So here we've got f of x equals x minus 3 squared plus 3. So the vertex would be at 3, comma, space 3. So hk, x minus h, okay. The axis of symmetry is an equation, x equals 3. A lot of people last quarter missed this problem because they didn't put in x equals. They just put in 3. So now I know the vertex is at 3, 3. I need another point on the graph. So here's what I'm going to do. Given f of x equals x minus 3 squared plus 3. So the axis of symmetry is at x equals 3. The vertex is at 3, 3. I'm going to pick another point. I'm going to use an x value that's right next to the vertex x value. So I'll put in a 4 or a 2. F of 4 is 4 minus 3 squared plus 3, which is 1 squared plus 3, which is 1 plus 3, which is 4. 4, 4. Okay, so now we'll go back over here and 4, 4, and there it is. And let's see if I did it right. And there you go. So the vertex is at HK, the axis of symmetry is at x equals h. So the big formula of the day is this: y equals a times x minus h squared plus k. The axis of symmetry is at x equals h. The vertex is at hk. If a is greater than 0, it opens up. If a is less than 0, it opens down. If this is y equals x squared, if a is greater than 1, it's going to be inside. If it's less than 1, it's going to be outside. Okay? And I'll bet you're worn out, but there you have it. Thank you very much, and I will see you tomorrow.